Hello, algebra students. Mr. Lawrence here. Hopefully there's no background noise. I'm at a McDonald's. My kids are having breakfast and playing on a play place. And I'm recording this lesson just for you. All right, today we are going to be able to add and subtract polynomials. And I know I've used the word a little bit, but not a whole lot, so you're probably wondering what a polynomial is. Remember, it's not when you forget to feed your parrot. All right, so anyway, Jeremy, are you listening? Did you get that joke? It was a pretty bad one, I know. Just want to make sure you're listening. All right, Kelsey, I'll bet you know what the prefix mono means. Mono means one. And when we have a monomial, we have one term. For example, this is a monomial because it's one term. Okay? This is also a monomial. This is a monomial. This is also a monomial. It's just one term isolated by itself. Okay? And some of you are going to say, well, there's a 5 in it. Well, yeah, but the 5 and the x to the 6th power are being multiplied to make one number. We don't know that exact number at this point. At some problems we'll be able to figure it out. Not today, though. But because it's being multiplied, it's just one value. Okay? Now, I will bet you that Mr. Tomb knows what bi means. I'll bet you he knows that bi means 2. You know, like bicycle. All right, so a binomial means there's two terms. For example, x plus 5 is a binomial. 3x to the 6 plus 2x squared. That's a binomial. There's two terms put together. Okay, pretty easy stuff. By the way, on monomials, this is not a monomial. 5 is not a monomial. It's called constant because there's no variable. Okay, no number by itself is just a monomial. So binomial only means two terms. All right, try. Well, I'll bet you Jillian knows that try means 3. Let me go back to blue here. Try means 3. So a trinomial would be like this. Okay, or x to the 20th, 5x to the 20th plus, 3x to the 8th minus 6. That's a trinomial. Okay, and then poly just means that there's more than 3. Poly means many. Okay, poly means many. When you hear poly, it means many, many terms. And so if you have 4, 5, or more terms, then it's just a polynomial. Okay, so let's see how to add them. This is real simple here. You see, I have 5x to the fourth, and I have 2 more x to the fourth. Don't I have 7x to the fourth? All I'm doing is combining like terms. That's part of the reason combining like terms is so important, is that you're going to have to use it in this higher level math. See, I have 5x to the fourth. I have 2 more x to the fourth, so altogether I have 7x to the fourth. Now in a problem like this, I'm just going to combine like terms. I've got 2x's. By the way, this is a binomial, right? 2x plus 3. And 8x minus 4 is also binomial. So I'm going to combine my x's. And how many x's do I have? Come on, Nick, I know you know. I know you know that there are 10 x's, right? And then I'm going to combine my constants together. Didn't take my highlighter. And I have a positive 3 and a minus 4. And I'm hoping you don't make any mistakes on that. You should be an expert at that by now. That would be minus 1. There you go. You can't tell me what x is because there's no equation. You can't solve these because there's no equal sign. But you can simplify them, and that's all I'm doing, combining like terms. Now, I strongly recommend using some kind of system to group your like terms together. Right now on here, I'm using highlighters, right? And so what I'm going to do on this one, oh, actually, before I do the highlighters, I am going to change something. You see this negative in front of the quantity? He has to be distributed to all 3 members. So I'm going to multiply all 3 members by -1. I'm going to make him positive, change the sign, change the sign, change the sign. What did I do? I took a -1 and I distributed -1 times all 3 members of the trinomial. Okay, now that I've done that, I'll go ahead and use my highlighters and group my like terms together. So right here, I have x to the fifth. I have 6 of them. And here I have a -5x to the fifth, right? Okay, And this one I have 2x cubes, and they're positive, and notice how I grab the sign with it when I highlight. And then this one I have a positive 6x to the third power. And then, finally, I have a negative x and a negative x. Yeah, because I distributed that negative. So I'm going to combine my yellow ones together. I've got 6x to the fifth minus 5x to the fifth, and that is going to get me a plain old x to the fifth. I have 2x cubes in green, 6 more x cubes in green. I must have 8x cubes. And then the blue ones, I have a negative x and a negative x. I must have a negative 2x. And there you go. That's all you can do in that problem. All right, one more example, and then a different type of problem. Again, I've got a negative in front of a quantity. I must distribute it. So when I distribute, I'm going to multiply by -1. So that makes that a positive. Change the sign, change the sign, change the sign, change the sign. Now I'm ready to start combining my like terms. So I've got 6x to the fifth right here. Oh, I don't have any x to the fifth. All right, I'll move to a new color. Okay, I've got 4x cubes here, positive, right? Got to grab that sign. And I've got a negative 8x cubes right there. All right, now I'll do 2x squared and a 5x squared. I've got a minus 5x and a minus 10x. That might not be a good choice in color there. It's hard to see that negative. Let me change that. Let's see, how about, there we go, that's a little better. So that we don't lose that negative when we go to combine them. All right, ooh, I can't see because of sun glare. There we go. Okay, and then if I want to leave my my constants uncolored, I could do that, or I could, color them. Now, you don't have to use highlighters. I mean, you could draw circles around the x cubed, squares around the x squared, or something like that. But you have to do something that will allow you to notice what the like terms are. Okay, I didn't use highlighters when I was your age. I used to use polygons, different shapes. But as long as you can see what's going on. All right, so 6x to the fifth is the only one in yellow, so I have a 6x to the fifth. In green, I have 4x cubes and a negative 8x cubes. Well, 4 minus 8, negative 4x cubes. In blue, how many x squareds do I have? I have 7x squareds. In pink, how many do I have? I have a negative 15x. And then in the dark or the magenta, I have a plus 11. Okay, so my answer ends up being this long polynomial here. 6x to the fifth minus 4x cubed plus 7x squared minus 15x plus 11. Again, I don't know what x is. There's no equal sign. I can't solve for it. We will learn how to solve things. We won't learn how to solve something this complex. Okay? Tell you the truth, I'm not sure I know how. It would be a very difficult process. Okay, so now we're going to calculate the perimeter of these two polygons. All right, and you should know perimeter is the distance around a polygon. The distance around a polygon. Okay, you should know that. I expect you to already be a master of that. If you have holes in your learning from geometry because you didn't learn it last year, you need to learn it on your own. If you want to come see me for help and I'll help you with it, absolutely, but I don't have time with the algebra curriculum to teach all this extra stuff for you. Okay, so we're going to calculate the perimeter. Now, this is the same problem as the ones we've just did. It's just as easy. Look at right here, I have an x, don't I? And here I have a 5x, and here I have 3x, right? And then, oops, right here I have a constant of a positive 1 and a constant of a positive 2. Well, the perimeter of this polygon must be 9x, 5, 3, and 1 make 9 x's, doesn't it? Okay, so I have 9x, and then in blue I have two constants totaling 3 centimeters, and there is your perimeter, 9x plus 3 centimeters. Okay, on this rectangle over here, and I am telling you it's a rectangle, well, think about it. The answer is not 11x squared plus 2x plus 8. Because if you did that, you did not do the entire perimeter. You only did half the perimeter. Remember that in a rectangle, these sides are congruent. And these sides are congruent, meaning they have equal measure. So this is also 5x squared plus 3. And this side here is also 6x squared plus 2x plus 5. All right, so now I'm going to go ahead and combine my like terms. Now, look, this highlighting technique is good, but you guys are honor, so I expect you to not need it for very long. Once you see what's going on, you should be able to combine your like terms. All right, um, I'm going to do the constant of 3 and 5 and 3 and 5. And the two X's, I'm not going to highlight because that'll be how I group them. They'll be the ones that are unhighlighted. So how many x squareds do I have? Well, I have 11 and 11, which would be 22x squareds. How many plain old x's do I have? It looks like I have 4 x's. How many constants do I have? It looks like 16 centimeters, and there you go. All right, that's your lesson for today. It should be pretty simple. You got to watch for that distribution. A lot of you won't. You'll show the distribution and then you won't do it. Okay, Mr. Lawrence signing off. Good night, everybody.